const pi, let's say int pi is equals to 3.142. Okay, this is something that is okay, something, a value of type double can't be. Oh, yeah. I have made a mistake that I have just come from warning you about. So this is supposed to be a double. I'm sorry. Int is used for whole numbers. Yeah, so these const and final keywords, they are not used interchangeably per se, but const is used when you have some values that are not expected to change anyhow. Like we all know that pi is 3.142. Like you cannot initialize pi again with a different value. Pi is like you can say universally known to be 3.142, and also inside your code base you want to keep this value just as it is. So in that case you use the const keyword. But for normal like variables that you're using inside your code, I think final keyword is sufficient. There is also the var keyword for initializing values. Var keyword is used when you do not beforehand know the data type of this uh, value that you are assigning to a variable. For instance, the student score. Let's say it is the time that these students are doing their exams, and you don't have those scores for a particular student. So you can't say if this will be an int, if this will be a double, or whatever the data type that you are expecting. So you just use the var. It's like a wild card for that matter. And you have val student score. Let me just comment this out. Just like that. So var, you just initialize it as it is using the var keyword. And the use of this is also, okay, it is kind of discouraged to use var if the data type of this thing is known. Like for our case, you know, student score can either come in as an integer or as a double, you know. So there are some systems where you know that there will be no decimal places that will be allowed. So in our case, you can just replace this with final int. Like you already know that for this specific type, for this variable, only values of this specific type are allowed. But if you don't know that, you can just use the var keyword. I hope that is not contradicting with itself. And also the not equal operator. Yeah. So the final one is this not equal operator. So not equal works the same way as the other operators that we had seen. That is the greater or equal. You can also have the not equal operator. Let me just delete all of this. Sorry. So we have, let's say, final int, int score grade. Let's say grade 1 is equals to 10, 20, like that. And then final int grade 2 is equals to 5. Simple. Then you want to check if these two are equal. So just print, let me have this with some space. So I'll just print grade 1. If you want to see if the values are the same, you have the equal sign. So you use this double equal to check for equality. That is equal grade 2, like that. And we have said that operators always return either true or false. So this equal operator checks if the value of this grade 1 is equal to the value of grade 2, and then it prints the outcome. In this case, when I run this, you will see false. Why? Because 20, which is grade 1, is not equal to 5, which is grade 2. And then if we have this 20, so that both of them have the same value, and I run this, yeah, you'll see true will be printed. This means the value of grade 1 is equal to the value of grade 2. So if I return this, if I revert this to back to 5, if you sometimes you may want to check if these two values are not equal, and that is when this not equal operator comes to play. So you just have this exclamation mark and the equal sign. This means that grade 1 is not equal to grade 2. So is 20 not equal to 5? Of course, yes. So the answer will be true. If I run that, yeah, true will be printed. Why? Because 20 is not equals to 5. So true will be the outcome. Yeah, thank you so much for that reminder. Uh, uh-huh. Yes.
Or you can check the Q&A part. There's some questions that have been posted there.
Oh, okay, okay. Thanks for that. I think uh-huh. Yeah. Remember, this is ahead of time compilation different from intelligence. I think I don't know what like intelligence really means, but I presume you're meaning like the one that like it helps you with code completion and helps with coding. I mean, uh, like okay, I don't really get I don't really get what you mean by intelligence, but ahead of time compilation is whereby the compiler itself is able to like detect some errors or issues with your code before you even run the code like for compilation. Yeah, that is the ahead of time compilation. You can check it in the dat website. They have, if you come to dat, I think dat dat.dev, yeah, you'll see you'll read more about ahead of time compilation there. Uh-huh. To which extension to install for compilation of that code. So when you install Flutter and then you run VS Code, there is this, where is this? Flutter extension. Flutter, yeah. This Flutter extension, uh, it you can see it is written Dart code. So this extension automatically installs this Dart extension. You don't have to install this. The moment you install this Flutter extension, it just installs the Dart extension automatically. So you can just create Dart files and run them direct in your code editor. Yeah, you can also run that online using this datpad.dev. I think datpad.dev, if I'm not wrong. Let's see. I really hope this is the one. Nice. So this one here, you can write your code here online and then run it, and then you'll just see the output on your browser without installing that in your system. But it is really encouraged to just use your system because you'll also be using this for Flutter. You see? Yeah. So I think we can continue because of time. I'll move on fast now. So we have covered this, the if, else if, and then the operators, and then we'll move to functions very quickly. So functions are blocks of code, blocks of reusable code that perform specific tasks. They have a name, the parameters, which are optional, and a body where the logic is defined. That supports both named and positional parameters for functions calling. You can define functions that return values using the return keyword. So this is what a function does simply. So let me give you an example of yeah. Uh, when you have, let's say you have one class students and you want their mean grade, what do? You simply take all their marks and add, divide by the total number of students. You see, that is very simple and straightforward. But let's say you're doing this for 10 classes inside the school, and then you'll do that for 14 schools in one sub county, and then you'll do that for 100 sub counties inside one region, like that. You see, doing that, adding of all students and dividing by their individual numbers, and then doing that for all those classes will be a tiresome manual task. But what if now you have some procedures or some algorithm or a program that you just feed all those numbers, and then it will give you the uh, average just directly. You see? So that is the whole like scenario of functions. Functions is a block of reusable code that instead of writing that operation over and over again, you just bundle it into some block of code, and then you will reuse it over again instead of writing the whole code. Simply, one of the simplest examples given when dealing with functions is a function to add two numbers. And for the purposes of time, I think I'll just employ the same function. So outside this main function, this is where we'll write our function, and then we'll call it inside here. So the first thing that you do when you are writing functions is you give the like this the data type of what you're going to return from that function. So in our case, we are dealing with numbers. So you're going to add two numbers, and then we will return the sum. Okay. So that sum, we also want it to be a number. So we'll start with int. Int is the data type of the return variable. Okay. And then after giving that, you give the name of that function. In our case, we'll name it add number adder, or add numbers simply. Add numbers. Okay, so this is the syntax for writing functions in that, and you'll see it is just okay, it is similar to most of other programming languages that you have interacted with. And then we have this parenthesis. So inside this parenthesis is where you have your parameters, the parameters that you want to pass. They are optional. A function can have parameters or can choose to not have the parameters. So we'll first start with the one that doesn't have any parameters. So after that, then you open your curly braces and then click enter. So inside here is where you'll write the operation that you want. So in our case, it is adding two numbers. So we'll say return, let's say what, a1 plus 3, like that. So you'll notice that this 1 and 3, we are first hard coding it here, and later on we'll pass it here as parameters, because you don't want a function that only adds 1 to 3. You want to give it some number and another number, and then it will return the sum. So for our case, we'll just have 1 plus 3 as hard coded values. So this function is returning an integer, of course, because we, at the back of our minds, we know that this is a 4. So this function returns 4. That's why we have integer as the return type, as the data type of the return value 4. And then, yeah, so this is basically the syntax of writing a function. If you want to call this function, you'll come inside our void main. And since we know that this is returning an integer, we can assign it directly to, yes, Alex, Flavian, anything maybe. Flavian, I think if there is no issue, you can kindly mute your mic.
Yeah, so
Okay, thank you. So inside this void main, you already know that this is returning an integer, so you can directly assign it to some variable. So final sum is equals to add numbers, just like that. We say that everything in that is like an object. So this add numbers is a function, but it is returning some integer. So that integer, all of this is representing this integer that is being returned from here, and you can assign it to this sum directly, and then you can just print the sum, that sum, like that. So if I run this, you'll see 4. Let me bring this up. Yeah, 4 is being printed. So what is happening? So final sum is being assigned to these add numbers. When you come to this add numbers function, some operation is being done, and then it is returning some integer, and this integer is now being assigned to this sum variable, and now you are printing the sum variable. So this is how we simply write functions. So functions can have a return type, or some other functions don't have return types, and those are void. So you just have void, and when I replace that int to void, you can see this is bringing some issues. Why? It is saying, if I can scroll this slowly, a value of type int can't be returned from the function add numbers because it has a return type of void. Yeah. So another really cool feature about that is that the error messages are so friendly. Like, you can read this and understand where you have done the mistake. So void functions don't have this return keyword. You see, so they can be doing some operations like this. They can be printing something. Let's say print hello, hello, but there is nowhere where we will have some return. You see, they'll just be doing some operations inside them, unlike the int. Let's say an int function, when I change back this to int, you'll see it will bring some error. The body might complete normally, causing null to be returned, but the return type int is a potentially non-nullable type. So what is it recommending you to do? Try adding either a return or a draw statement at the end. You see, so we'll have here our return. So I'll just do away with this, and then we will return this, like that. You see? Yeah. So I now want us to pass some parameters. So I don't want this 1 and 3 to be hard coded. So what you do, if you want to pass this as parameters, you just have the data type, that is int number 1. This is the first number. Then you have a comma, and then int number 2, like that. Simple. So what we have done is that inside this parenthesis, we have given these parameters that will be passed to this function whenever it is being called. And then we'll now use these numbers. Instead of the hard-coded 1 and 3, you'll just have number 1 plus, sorry, plus number 2, like that. So with this, we remove the hard coded nature of this function. This means it can be called multiple times with while passing different values, and then their sums will be returned independently. So when you come back here, you'll see now that this is bringing an error that two arguments are expected by the add numbers, but 0 are found. So in our case, we'll pass the two numbers. What is this? So you'll just come inside this function. So here, final sum will be you'll now give the value of the first number, that is, let's say 10, and then a comma, then the second number will be 5, like that. So you see the compiler is quiet and it is happy now. So we are now saying that while we are calling this add numbers function, we want to call it with 10 and 5 as the arguments. So these are the parameters that we gave here. We wanted one integer, that is number 1, and another integer as number 2, and then we'll return number 1 plus number 2. So in our case, this is 10 plus 5. So the sum will be 15. So we can have sum1 as 15. So we can just name this as sum1, and then we'll print it here. And then you can now call this function again with a different set of numbers. So we'll say final sum2 is equals to add numbers again. Number 1, we'll give it some a big number, let's say 120. And then number 2, we'll give it some 90. Okay, so as you can see now, we can reuse this adding of numbers function multiple times without having to say like add 10 plus 5, add 190 plus 120 plus 90, and you can reuse this function over and over and over again easily. So, yeah, so we'll just print sum2 semicolon over there, and just to add some more context, we'll have sum3 is equals to add numbers 556 and another random number, let's say 89, like that. Then we'll print sum3 like that. So add numbers is just a function. We have written it outside our void main. Its operation is taking one number and adding it to another, then returning an integer. So this doesn't care where it is being used. Only what it takes care of is whatever is inside these curly braces, and this is the operation that we want to be done by this function. And then we can call it multiple times, either as without parameters if it doesn't need them, or with these arguments, that is 10, 5, 120, 90, 56, 89. This is the ones that you have given here. So let's run this quickly and I will see. So the first one is 15, that is 10 plus 5. The next one is 210, that is 190 and 120 and 90. And the third one is 145, that is the sum of these two. Yeah, so basically that is how we have functions. Main itself is a function. If you have noticed, it is a function. That's why we never have any return inside here, because it is not returning anything, the main itself. Yeah, so all this time you have been writing this function, you have been executing this, only that this main is reserved for the Dart compiler itself to carry out the operations inside here, but itself is a function. There are no arguments inside the main function. Yeah, only the whatever is inside here is that matters. I hope there are no questions with functions. Any issue with functions before we go to the final, the final step? Let me skip these collections for now and first look at classes. So the thing is, so let's look at classes now. I'll delete all of this. I hope there are no questions up to that point, and if there are any, just feel free to type in this in the chat section. So another concept about that is classes, and what classes are like blueprints of something or some objects in your in your code, like, or in your application. Simply, what a class is like a description of one thing inside your code. let's say for example, you are defining a student. Okay, so what properties does a student has? Let's say they have their registration number, they have their name, they have their let's list down them here in a comment. So we have the name of the student, we have the registration number, we have the class they are, we have the age, we have all these attributes. So if you want to like create some blueprint that applies to all students, because all students have these attributes, you see. So what do, you create a class. And this is how we create a class. First of all, you give the class keyword, so class, and then you have the name of that class. So in our case, this is student, and then you have the curly braces, as simple as this. Okay, so we have class student, and then inside here you will define all these properties of a student, but without assigning them values, because you want this class student to apply to all students in your school. Okay, so first of all we have the name, which is a string, so we'll have final string name, like that. Don't worry about this error, we'll deal with it in a few. And then we move to this registration number. Okay, for the purposes of brevity, we'll just remove one property. We'll have name, reg number, and the age. So okay, I wanted something that is not of the same data type, so let's say name, age, and let's say weight. Yeah, we have the weight of a student. I want a decimal over there, that's why. So we have the name as a string, age as a whole number, that is an integer, and then the weight as some double. So we have final string name, then we have final int age, and then we have final double weight, like that. So after you have defined this, you create now a constructor. So a constructor is like a statement that will help us create instances of these students anywhere where we want to initialize a student, a specific student. Okay, so this is how we write a constructor. So just like this, create constructor, like that. So what I've used is these, let me have a comma over here for formatting purposes, like this. So what I have used to create this constructor is some extension called data class generator. Data, that, data, what is wrong? Yeah, this one, that data class generator. So it creates for you a constructor. So what a constructor is basically what attributes of these students are needed when you are creating an instance of a student anywhere in your code. So that not to make this a little bit confusing, I'll just have okay, I'll just have my void main down here. So this is void main. I don't want this to be confusing, so I'll have my void main. And then so inside here we want to create one student. Okay, so how do we do it? You'll have final student one, let's say student Victor. No, let's have student one, like that, is equals to, and then now you have the student class over here. So you'll just have student, student, then we'll have the like that. So inside here, so what we are doing is we are creating an object that is student one. So we are creating one student, but it must have all these properties. But how do we avoid someone adding more properties or giving less properties? By creating a class. A class will give us a blueprint of how a student should look like. In our case, a typical student should have a name, age, and weight, only those three. So if you want to create one student object, you must use this student class. You see, so this is the use of a class. It helps us organize data, like by creating blueprints of different things inside your code that should have the same attributes. In our case, the name, age, and weight. For all students must have a name, and, some age, and some weight. So you are creating this student one object by having an instance of a student. Then inside here is where you'll have your properties. So we'll have the ages, let's say 20, and then a comma, and then the name. We'll have, that's the string, so we'll have Victor, and then comma, and then the weight, that is a double, so this will be 60.9, like that, nice and easy. Yeah, so what we have done here, we have created this student one object, but we have used the student class as a blueprint. Like, it is giving us the guidelines of how this specific student should be. Yeah, and then now you can now do things like printing. You can print student one dot name, that is Victor. So if I run this void main, you'll see that Victor is student one's name. So the use of a class is that you can now create different students, but using the same blueprint, that is the student class. So in our case, you can create another final student two, student two, student two, like that is equals to student, the class now, and then at the end you have the semicolon. Then inside here you'll just give the properties, the age. So this one will have an age of 30, weight of, let's say, 34.5, and the name of Irene, like that. Okay, so as you can see, we have created different students, but all of them have the same properties, guided by the student class. So this is basically the use of a class inside your Dart or Flutter code. In Flutter, a class will also be called a model. It will be used to model specific things in your app. Let's say, for example, a user in your application. You want all users to have the same characteristics. That is the username, the user email. You want maybe to get the user ID, user phone number. Okay, so you just create one model, that is one class. You stipulate all those attributes. There are also, you can also create functions for a specific student. I think because of time, we'll not have to go deep into that. And yeah, so this is how we create classes and use them in Dart. Classes basically give us a blueprint, like some guidelines of how a specific thing should be and how it should behave. And then when creating these objects, they will have the same properties or the same behaviors. If time will be sufficient, we would look at different having functions inside classes, having some attributes that are optional instead of all of them being required and stuff. But because of time, I think it's best we move to the next thing. You can also mention something about name argument using the required keyword. Okay, I've said that because of time, I think I'll just brush through this as they are. When you go to the flatter part, I think from next week, we will be looking at those named arguments of functions, required arguments, optional, positional, and all those stuff. I just want us to get the basics of how classes work, how functions work, and all that stuff. Yeah. So the final thing that I wanted us to look at, the one that I skipped, is collections. I don't think there is any other thing. Best practices. These I'll just send these slides and you look at the best practices. And yeah, so there are these collections. So what collections are? I think I can delete this. Yeah, I can do away this class. We are done with it. And also this. I'm running a bit because of time. You can see it's already past 9:30 by 10 minutes, so I'll make this as quick as possible. So what collections are in that? Uh, they are like containers for storing data. Uh, yeah, just that containers. Okay, when you have data, you can have data that is multiple, and then you can store it. You can store it in different ways. For example, we have a list. Let's say we have lists, then we have maps, other collections. Let me check. Lists, maps. Yeah, okay. Primarily, we have lists and maps. These are okay. Yeah. So basically, we have lists and maps. These are the two most commonly used collections. And what lists are? They are a collection of variable or data, and they are unordered. That means you can have different data types of items in a list, and they are zero indexed. That means the first thing is at index 0. Yeah, okay. I think I should be doing it as I am talking. So the way we initialize the list is the same as how we were initializing variables. So you'll have final list. You have the list keyword, final list. What do we call it? My list. So this is just a custom name. You can name it however you like. You can have a list of scores. You can say student scores. Have a list of anything, basically anything. But this is the list. This is a keyword. So final list, my list is equals to, and lists use these square brackets. This is how lists are shown. And then you have a semicolon to terminate. So inside here is where you will put your values for this list. We can have a list of same data type values or different data type values. So let's say the first value is a Victor. This is a string. And then if you want to move to the next, you separate items in a list are separated by commas. So I'll have, so this is the first item. Second item can be an integer, sorry, can be integer, let's say 2024. And then we can have another string, yes. Then you can have a bool, true. If you remember about true and false, that is a value. You can have another number, you can have a decimal. Like basically lists can hold values of different data types or values of same data types. If you want a list to hold values of the same data type, what you do is you specify that data type here. instead of having it as list, if you want this to be only a list of strings like Victor, yes, and strings, but you don't want it to accept these other values, you have this, I don't know what they are called, these symbols, these greater than and less than symbols. And inside here is where you give the data type that you want this list to only have. So let's try with the string. So what you're saying is that you want my list to only have string values. So when it was like this, uh, just like that, this list was holding different data types. You can see these are string, this is an int, string, bool, double. But if you specify like that, you have these symbols and string, you're giving it some restrictions to only hold string of values. So when you come here to 2024, it will tell you the element of type int can't be assigned to the list of type string. Like that. Also, the same for the bool can't be assigned to this list of type string, and also for this uh, double, if I may. Yeah. So this is how you specify a list to have only one data type. But if you want it to have mixed numbers, you can just omit that and have it as a list. So yeah. Then if you want to access items in a list, you use this is a syntax. So let's say you want to print this 2024. Earlier on, I said that lists are zero indexed. Zero indexed means that this the first, what appears here as the first value is at index 0, not index 1. Like if you want to access this, you can't access this, you can't access it as the first value. You access it as the zeroth. I don't know if zeroth is a valid English word, but this is the first value, this is the second, this is the third. So the first value starts from what appears as the second one, like that. I hope it makes sense, but let's make it make sense. So I'm going to print the zeroth value and then the first value, and you'll see what I'm talking about. So we have a print statement over here, and then my list. So my list is a list, but you don't want to print the whole of the list. You only want this item. So we'll have these square braces, and then you have 0. So this is how we accept, this is how we access values inside a list. You use these square brackets, and then you give the index. So if I print this 0, 0 index, I expect this Victor to be printed out. So if I run this, yeah, so Victor gets printed. Then if I print index 1, now we move to 2024. So quickly, this is this. You can see 2024 is being printed, and then this is 2, this is 3, this is 4, and so on and so forth. So basically, this is index 0. So like this is like saying this is the 0th item, then the first, the second, the third, and going on down the list. Basically, that is all I can say about the basics of a list. There are list operations. There are functions. There are functions that you can carry out on a list, like list.length. You can print the length of a list by printing my list.length. You see. So if I run this, it will print, it will count, it will basically give me a count of how many items are in this list. In our case, this is 5. So if I remove these 2.3 and then I run this again, you can see the length will be 4, because this is 1, 2, 3, 4, 4 items. But the index, remember, this is 0, this is 1, this is 2, this is 3. Do not confuse the length with the index. So there are a lot of functions that you can carry out in a list, like this for each, dot map, and all those join, last, remove, retain, replace, set range, and all this. We'll look at them when we get to the flatter part. You just have to know that this is how a list basically operates. Then the next and the last thing is maps. So maps are key value pairs. If you have done some Python, you have interacted with I think dictionaries. They are called maps in Dart. I don't know how other programming languages like call them, but basically they are key value pairs of items, and this is how we declare uh, maps. So we have final map. So you write the final and then map keyword, and then you have the same these symbols, the less than and greater than symbols. And inside here, you give the data type of the key and the data type of the value. For instance, let's say string and then comma and then int. Yeah, and then now you give the name of that map. Let's say student scores. So you want a map of string and integer of student scores. Don't worry about the map. We'll see how we'll initialize them. So basically, we use these curly braces to to indicate maps. For list, we use these square brackets, but for a map, we have curly braces and then we terminate it with a semicolon. So inside these braces, the way that we the way that we write maps is by having keys and values. So we have given here string to be the value of keys and integers to be the value of scores. I mean the values. Integers, we have keys as string, values as integers. Uh, I don't want this to be confusing, so I'll just give the scores direct. So I will have the keys as the names. So I'll just say Victor, and then a colon, and then his score as an integer, 80. Yeah, so this is one value. I mean, this is one item in your map. We have given this as a key type string, and then the value as type int, that is 80, and then they are separated by a colon. So this is one item. If you want to add another item, you use a comma, and then I'll just click enter. Then I will give the second value, that is the next one will be, let's say, Erin, like that, then a colon, and then their scores 67, like that. And then I'll maybe have the third one as let's say a John, simple, and then a colon, and then 20 as the value. So anything on the left is the key. So Victor is a key, Irene is a key, John is a key. And then on the right, we have the values 80, 67, and 20 as type integers. So the reason for giving these data types here is to ensure that you do not mix the data types inside here. You only want your keys to have a specific data type and your values to have a specific data type. And if I change something here, let's say I remove that int and I'll have string, you see? So all these 80, 67, and 20 will complain. Why? Because the element of int can't be assigned to map value of type string. So you really want to have these types are given here so that you do not mix types down the code. Yeah. So the way that we if you want to access any value, you just use its key. A key is like now the one that holds each value. So if you want to print, let's say the score for Erin, the syntax that we use for that is print, and then let me have this colon first, semicolon first. So the first thing you do is give the name of that map. So this is student's course. And then you again use the square brackets, the way you used here for my list when you are accessing the item at index 0. You'll use the same here, but instead of giving the index, because this is not a list, you give the key. In our case, the key is, let's access this John. We want 20. So you give John inside there, and then we run this. Nice and easy. So what will it print? 20. Okay, don't worry about this, Victor. I think I'll just comment this out. Yeah. So then let me run again. Nice. So you can see it is printing out 20 to the console. That is the value of this John key. So if you want to print out the key for Irene, you just replace this with Irene. Yeah. And then I run this. You will see 67 will be printed out. So this is how we access the values of any map using their keys. Yeah. And then there are also methods for maps. So if I write students course and then I write a dot, and there are this like is empty, this is a bool, checks if it is empty, it will print true or false. You can have the length also, the values. You can see values, it prints all the values. So if you want to print all these values 80, 67 and 20, you just say students course, that is the name of the map, dot values. If I run this, it will print out this set of values 80, 67 and 20. Yeah, there are a lot of methods that you can have here, but we will not go through all of them for now because also of time. And yeah, I think with that, oh, okay, any question up to that point? Just look at the charts. Anything? There is nothing in the QA. Yeah, yeah, okay. That is the basic, that is basically how that looks like. I hope this was a simple one. I hope you like that, because without liking that, Flutter will give you a pretty hard time. Yeah, I think I will share these slides first, and then I will also share some links about the some databases that you can look at, and which will explain all these things that you have discussed, but in detail with good examples. I mean, better examples. But yeah, my aim was just to give you like a basic understanding of how that works, and show you like how simple that is. And then when we pick up from there, I think Flutter will be easy for us to start. That is from next week. Thank you so much again for attending, and for being with being together up to this point. I have taken like some 28 minutes of your time, but I apologize for that. That is like there are a lot of concepts that we have not covered, but don't worry about that. We will be going through them as time goes by. Yeah. So I can see there's something here. Questions will be great. Thank you. Yeah. If anyone has a question, I think now is the best time to either type them out, or you can just unmute your mic and speak them out. I'll be sharing the slides to the WhatsApp group. So please make sure that you are in the group. The link is here in the chat. Yeah. Starting next week, we'll be starting with Flutter, and then with Flutter now we'll be doing the interesting stuff because that is the interesting part about it. We'll create beautiful applications. We'll look at widgets. You'll basically see that in action. This that we are learning here, because there will be things that we have learned here that are on the Dart side, that is about classes, the void mains, the lists, and basically everything that we have talked about here. It will be there. So yeah, I'm talking all these while I'm waiting for the questions or the schedule. Uh, you can reach me out on on WhatsApp, Twitter. I mean X. Yeah, X or Twitter also. I'll share my handles on GitHub also. You can check my Flutter projects and my Dart code and all those stuff. But in case you have any issue, do not hesitate to contact me, be it in Dart or Flutter, and I'll be happy to help you out. Yeah, thank you very much for joining. Uh, I think I'll give this chance to Alex if there is no any other issue that is. Yeah, Alex, I think you can take over.
Yeah, thank you very much, Victor. Yeah, for the session. I know right now you're just getting started. A time will come when our machines will be on fire when you're running the emulators and all that.
Yeah,
Yeah,
yeah, yeah,
so yeah. Yeah,
yeah.
so right now you're starting with the easy stuff, learning the Dart language, and then we'll now switch to the Flutter framework, where we'll now see that in action, just like Victor said. Yeah, so once again, this is Flutter Wednesdays, which means we'll be meeting. Thank you all for maybe can be free to end the meeting. The slides and the link
You can stop recording now.